The attribute is the one makes this protocol special. BGP is not a simple routing protocol just to you enable a protocol and advertise some network and get the route. No, that's not the main reason why we go for BGP. BGP has got very rich metric called attribute. Using attributes, we'll be able to select a path as per our policy. Path selection based on policy. That is very important. This is what we see everywhere today. If you take SD-WAN, in SD-WAN, what do? This is what we do. Here we are doing in CLI. There you are going to use a user interface. Simple. There is no other difference. People who come straight to SD-WAN without the knowledge of BGP, MPLS, they struggle a lot because they do not know what is really happening behind the screen. But people who learn systematically like this BGP, the MPLS, and all the other multicasting and things like that, for them, when they see SD-WAN user interface, it's boring for us. It is too childish. It's boring. Um, though the business people won't agree with us, but it's really boring. It is actually time killing. They say you create once the object, later you use it, it reduces the time. All those funny stories I cannot accept as a person who spent in networking for like 19, 20 years. Anyway, so learning like this, how BGP works, how the attributes are contributing in path selection based on policy is more interesting, more important. Now, as I said, attributes are the reason for choosing a path based on policy. And these attributes are characterized or classified according to the characteristics in various categories. Number one, so well known, mandatory, well known, discretionary, meaning an attribute which is seen in every BGP running appliance, regardless of vendor. Any device that runs BGP will have set of attribute. They are called as well-known attribute. But not all well-known attributes are mandate. So those that are not mandate are called as discretionary. Well-known mandatory example, next hop. There is routing protocol, no routing protocol, whether it is BGP or OSPF or RIP, no routing protocol advertises a network without a next hop. Next hop is very important, not only for BGP, any routing protocol. Without a next hop, what is the point of having a route? There is no use of that route information without a next hop. Yeah, that's why it is well-known mandatory. BGP calls it as well-known mandatory. Next hop must be there in every advertisement. If not, will be discarded. Won't be accepted as a valid update. Secondly, the origin. How this network is introduced, how this network is introduced in the normal routing protocols like OSPF. We introduce networks into OSPF in two ways. One by advertising using network command, the other one is through redistribution. Same story is also applicable for BGP. We advertise by putting network command. Those networks, when the other router learns, they learn it with a symbol, a character I. And if you redistribute a network from some other source into BGP, then we have question mark. If we will redistribute from one specific protocol called EGP, then we'll have E. E for EGP, which is no more seen in routers. In case if you have one, which is an early version of BGP, I can say, then those routers that runs the EGP may not have BGP. So when you learn route from EGP, we need to redistribute it to BGP. Those routes will have E as the origin. This we called as IGP, but this IGP is not interior gateway routing protocol. This IGP means they are BGP's own network, advertised using network command. And this one we called as incomplete, meaning redistributed networks from some other source. All these three are well-known mandatory. What are the three? Number one, next hop. Number two, I did not say that, local preference. Local preference is also well known, but not mandatory. AS path, and origin. These three are well known, mandatory. Now, local preference is well known, but this won't be seen in the updates coming from eBGP. Though it is well known, it is discretionary. It's not seen when it is coming from, when an update comes from eBGP, which means it is not mandated. But you cannot use the word optional because it has got another meaning. Later we'll see that. So local preference is well known, discretionary. We will also be seeing another attribute called multi-exit discriminator, MED, that comes under optional non-transitive. Optional non-transitive. Now what is optional? Optional attributes are the one which is not necessary to be seen in all updates, though it is not necessary. If a vendor device says, I want to see it, otherwise I will not use it, I will not use the update, then such attributes come under optional non-transitive. I repeat, though it is not a needed one, the attribute is not needed one. I have a petrol car. A diesel is a tin of diesel is not needed. But if someone insists saying, I need that diesel, a tin of diesel, only then I'll start my car. Otherwise I won't start. Though it is not needed there, it's a petrol car. It never you will need a diesel, a can of diesel. But a driver is stubborn saying, unless you buy a can of diesel, I won't start the car. Such attributes which are not really needed, but still I want to see it. That is what optional non-transitive. MED is one such attribute. MED will never be needed, will not be needed, no need of using MED whenever you have multi-homing. So for this autonomous system 10, autonomous system 20 and 30 are the upstream autonomous systems. This is multi-homing. MED will not be able to make any difference even if you tune MED in this topology. It cannot make any difference. MED is used only in dual homing scenario. Only one upstream on the top, but multiple connections to the upstream. Only in this scenario, MED will come into picture. MED will be useful if you tune, but EBGP updates are invalid if MED is not there. At least the default 0 should be there. MED by default is 0. It's a numerical value. Smaller is preferred. Even though it is not going to be useful, that MED must be there in every update. If not, this router which is receiving the update will discard it. Such attributes are optional non-transitive. If in case a router accepts without MED, then it is optional transitive. Right? Optional transitive, but actually no routers will accept as per the standard they are designed. MED should be seen, though it is not that important in a multi-homing scenario, but you still need it. If not, it will discard that. So we call MED as optional non-transitive. If any vendor says it is okay, even if it is not there, I'll still consider that update as a partial update and I'll use it, then it is coming under optional transitive. I don't have an example for optional transitive in Cisco. Now, a clear definition for well-known, mandatory, and discretionary. Have a look, just take a minute and read, and if you have a question, let me know. The other one, optional transitive and non-transitive. The sentence may or may not convey the complete meaning of what I said. Just go through it and let me know once you are clear. Here we have few attributes. The attributes that can be used by us to manipulate, used by us to change the path from the default. The other attributes are just used, they can't be altered by us. We can't tune them to take a path. That is just to show why this path has been taken. So these are the attributes that are configurable, that can be used by us to do some changes. We'll see all the attributes in a few minutes. Now let's first go through these attributes and understand one more time. We know what it means, AS path. We know what is next hop. And I also explained what is origin. We'll see one more time. The local preference and MED may be new to you. Now let's finish these things, then we will get into the sequence of attributes and how they are used in path selection. As we know, when a router advertises a network, it advertises along with its autonomous system number. And the receiving router knows the next hop as well as the autonomous system of the next hop. In our case, C learns this 192.168.1.0 with the next hop an address on this port, maybe it's not mentioned there, and with the AS number 64520, like this, 192.168.1.0. The next stop, it's not mentioned there, so let me write next hop. And you will also have AS path like this, 64520. Now when this is advertised to router B, C will put its own autonomous system along with the autonomous system that it has learned. So it appears like this on B, 192.168.1.0. The immediate autonomous system 65500, and then the next autonomous system to this autonomous system 6500 is 64520. So B not only learns the adjacent, it also learns all the autonomous system in the path. Now in the list, the very first one is the immediate autonomous system number, and the last one is the place where the network originated. In our case, we have only two, the first and the last, or just two, but in the real world, you may have 10 autonomous systems. And the first one is the next autonomous system, the 10th one is the place from where the network originated. This is a well-known and mandatory attribute. Yes.
So when it comes to AS path, do we have any limitations like the BGP can learn only
No.
20 AS number or
No, there is
10 AS number? No, right?
no limit. There is no such limit. Now, next hop attribute.
So the local.
Next hop attribute, we learned this earlier, that in eBGP, the next hop will be the immediate router's address, but in IBGP, that is not guaranteed. Why? eBGP's address is always carried into IBGP. To override that, what we do? We say next hop self. Right? If you want to change the next hop, we say next hop self. When we don't say that,
It will not know the.
yeah, C router will have next hop as this address for this network, because eBGP address that comes to B will be carried into IBGP. Now next hop is a well-known mandatory attribute. About this we saw, but what we have not seen is I is smaller than E is smaller than question mark, smaller is preferred. So I have three sources giving me same network. Three sources are advertising me path to reach a network. One source says I, the other source says E, the other source says question mark. I have to prefer, my router will prefer smallest. I means BGP's own network giver as a next hop, network giver. And if I don't have I, then E is preferred over question mark. Okay, so these are all only if the attributes above this origin, see there is a list, there is a sequence, and attributes are checked in sequence. Origin comes after AS path. Origin comes after local preference. Local weight will be there. There is another attribute called weight. Then comes the local preference, and then comes the AS path, and then comes the local origin, and goes on, and then origin code will come. Weight, local preference, local origin, and then AS path, and then origin code. So if there is tie in the above, only then this comes into picture, otherwise this won't make any impact. We'll see the sequence in some time, but what I'm trying to say here is, if I know origin and if I don't know other attributes, if I know only how to tune path using origin, not enough. No, that is not complete knowledge. I can't achieve what I want. So we need to know all the attributes, how they work, and which comes after what, all the stuff. And now next thing is, origin is advertised to all autonomous system in the internet works. As I said in the previous class, someone in Perth advertises a network, and someone in Chicago knows that it is being advertised, not redistributed. How? Its origin is informed, advertised to every autonomous system in the path. Origin is well known and mandatory. Any question? This is the command we often use to verify the BGP's condition, not the neighbor condition. After forming neighbor, I want to know what all I advertise and what all I learn from others. The network that I advertise will have next hop 0000, and if the next hop is 000, automatically the weight will be set as 32768. If you want to change, you may change it, but it is changed by default. It is given 32768 by default for the local origin network, for a good reason, because weight is the very first attribute. When we go to the attribute list, again we will discuss this. Now what I want to say is, this is what called as local origin. This network is advertised locally. This network is also coming from a neighbor. Which one it will prefer? It will prefer local origin, because local origin will have high weight. Now, this is what the origin code. Origin code means how it is introduced. These networks are advertised, not learned here because of somewhere someone redistributed. These networks are advertised. What else we learned? What about this I? This I means this, internal. See, there are two I's. Alphabets, we have 26 alphabets. They could have used something else. I don't know why they confused like this. Two I's. One is origin code I, another one is local to the same autonomous system. This network is within the same autonomous system, not coming from somewhere outside. This I means from the same autonomous system. What else we saw? Next stop we covered. Okay, AS path. This is the autonomous system originally advertises this network, and this is the autonomous system advertises this to the autonomous system in which this router A is path attribute. Do you have any question on this page?
No.
That's great. Local preference for the entire autonomous system. I want to draw a router C here. And you may have many more. I just have 3 routers. Assume it as, take it as 30 router also. Never mind, 300 router. If I want all 300 router to forward the packet to A, not to B, to A to reach this network. If I want all 300 routers, including B, to reach 172.16.0.0, there are multiple paths here, more than one. We may exit via B, we may also exit via A, but if you prefer to exit via A, all 300 routers, all that we need to do is just go to A and set high local preference. You don't need to inform the other 299 routers. The moment you set local preference higher on one of the route, higher is preferred actually. The default is 100. The moment you set the local preference higher, this information will be advertised to all IBGP neighbor. All the routers now know how to leave their autonomous system. And now all will prefer going out via A in spite of the hop count, 1, 2, 3 hops. Whereas this way is just 2 hop. Even though the hops are more via A if I exit, but still it goes through it because AS path attribute comes after local preference. Local preference comes first. Local preference comes before AS path. So you may use this one in order to tailor the direction. If I want to exit on A, I set high local preference on A. All right. So well known and discretionary, very important. This is well known, yes, every vendor knows it, but it is not advertised to EBGP neighbor. It is not advertised to EBGP neighbor. Even though it is not advertised, EBGP is not going to say, I'll consider it partial. No, no. It is well known discretionary, meaning even if it is not there, it is fully qualified, not partially qualified. If it is an optional transitive, then it is partially qualified if it is not found. Right. Now, local preference is used to advertise IBGP neighbor about how to leave their autonomous system. Local preference is sent to IBGP neighbor only. It is advertised only within the AS. Local preference attribute is known as well-known discrete. Okay, the default is 100. Higher is preferred again. Higher is preferred. Any question?
Can you go to the previous slide once again?
You see the default local preference is 100 and local preference will be appearing here if it is coming from the member of the same autonomous system. From the other autonomous system, if it comes, then it won't. If it is coming from EBGP, it won't show you. It will be blank.
So do we have any chance to see about the metric like in further classes? Because I have seen like everything is 0.
Metric is MED. We will be seeing now.
Okay. Oh, that is a
Multi-exit discriminator.
combination.
Yeah.
Okay.
Multi-exit discriminator is what we call it as metric. Lower is preferred. And this is used only if dual homing comes into picture.
So when we will be using like
It's coming. We'll see. So far we have not seen. It's coming. I think very next slide is wait. All right, MED. MED is an optional non-transitive. See, though it is optional, it should have at least 0. That metric 0 MED. If it is not there, then it is discarded. That's why it's non-transitive. Comes under optional non-transitive. Now, lower is preferred. See, it is also called as what? It's also called as metric. Multi-exit. See, I have multiple exit. 1, exit number 2. Connected to the same autonomous system on the top, not two different autonomous systems. We call it as dual homing. Only in this scenario, MED will come into picture. How? If this autonomous system wants their customer to come this way instead of coming via sea. In order to reach the network, the upstream, I'll call it as provider wants to come to B, not to C. Only if B is unreachable, A can get in via C. Provider prefers A talking to them to B, not to C, and C can be used as a backup. In such cases, provider only sets this value. While advertising, it gets advertised, and this MED is learned by eBGP neighbor, which is A. A is an eBGP neighbor to B and C. Now that eBGP neighbor knows how to exit their own network. So A now knows that I have to go this way, not this direction. But again, I'm telling you, this is sixth attribute. If in A you set wait or local preference saying you go this way, it will go this way. Only when there is a tie in first 5 attribute, the attribute set by your neighbor autonomous system will make your router to decide the exit. Do you understand that? If first 5 attributes you did not set, and the first 5 attribute is a tie, and you got a dual homing, only on these conditions the MED configured by the upstream will determine the exit on the downstream edge router. If the downstream edge router have got something like wait or local preference, MED will not have any impact. Though you have dual homing, MED cannot make any change to your decision. Who is another autonomous system to decide what I have to do? So you have control. You can control by putting local preference or wait or something. Only when you don't do that, the upstream, they may be your internet service provider, they will have a privilege of taking decision on behalf of you. Any question?
So we will not use local preference and MED at the same time.
No, no, no. That's not the ISP will do whatever they want. We will do what we want. Only when we don't do what we want or we don't have anything in our mind, then there are chances that there will be a tie in the first five attribute. In such scenario, the sixth attribute, which is service provider's choice, that is sixth attribute. Service provider's choice. First five choice you had to make, but when you don't make, then service provider gets the chance of dictating your router how to leave your autonomous system to come to the ISP network. Lower is preferred. See, in the previous one we saw local preference. Higher is preferred.
Yeah.
We will be seeing next slide of a weight. Higher is preferred. In origin we saw small is preferred. MED is also small is preferred. Any question on MED?
No.
So for MED you need to have dual homing. For MED to make an impact, in router A, the first five attributes should be a tie. Only then this will have some impact. Two conditions. Weight is a Cisco proprietary attribute, but I see this attribute in Huawei. Same word weight is used. This is the first attribute in Cisco as well as Huawei, as well as Zati. Zati is another company. So, what is the difference between this and local preference? See, this says if you have more weightage to this neighbor, it will go this way than this way. The default is 0. Weight default is 0. Local preference default is 100. Let me show you weight. See, the default is weight 0. Now, higher is preferred. What is the difference between weight and local preference? Weight is local to the router. But I told you, local preference, if you configure 200 on A, all other 299 routers inside will know it and they will also follow the path via A. But weight is not like that. If you set on one router, it's only for that router. The other routers will choose according to their weight, their local preference, their attribute. So the weight that you configure on this router will not impact any IBGP neighbor or ABGP neighbor. It is not even going to be advertised. When you capture a packet, you won't see weight is, you will not see weight inside in the advertisement. So no other routers will know about the weightage, the weight that you have set for a neighbor on this A router. Path with the high weight values are preferred. Weight is not sent to any BGP neighbor. They are local to the router. Any question on weight?
Not on weight, but when we talk about metrics, we say like when we have a tie after the five, when we have a tie in all the five
Sixth one will come in.
attributes, then only we will call it. So, what are the five attributes? It's a local.
We are going to see that. It's in another next 2 pages. After 2 pages, we'll see. But I can tell you, because you have asked, weight is the first attribute. Local preference is the next attribute, and then locally origin is another attribute, and then AS path is another attribute. Origin code is the next attribute, and then comes MED.
Wait, local AS
Preference.
path next.
Hmm?
Okay.
Weight is the very first attribute. Local preference. What is the difference? Weight is local to the router. Local preference is for the whole autonomous system.
AS
Local
path.
origin, the one with the next hop 0.0.0.0.
Oh, okay.
For that, automatically 32768 weight will be set so that it will be there will be hit in the very first attribute. If the local origin is there, then weight will be automatically to 32768. Okay, next is AS path, number of hops to reach the destination. If that is also a tie, then it will check origin code. If all have the same origin code, like both the paths are having question mark or both the paths are having I, then again there is a tie, then only it comes to MED. But for MED, this topology will not be suitable. It won't make any impact. It will go to seventh attribute. EBGP is preferred over IBGP. So the sequence is very important. I know you are very curious to see, waiting for that sequence. Let's finish this and go. What about wait? Are you
No, I have an idea like okay, these might be the those five
hmm,
attributes that we need to consider before we go to metrics. So that's what I like to cross check with you whether I'm
okay?
in the right path or I'm just thinking or
Hmm.
thinking of the wrong one.
No, you're right. You are in the right path. Okay. Now let us move on to the next one. If you don't have any question on weight.
No, I don't have any question.
Now this is an important page. Just to tell you, it's an information to say that even though we have BGP, you cannot expect routing table manager to use only BGP. Routing table manager will have its own checklist. When routing table manager learns route for a destination from multiple source, it will always decide based on the administrative distance. IBGP's administrative distance is 200. OSPF is only 110. Now, which one manager will take? It will only take OSPF because it is BGP. It's not going to say, "Wow, hail BGP." No. If it is coming from EBGP, yes, it prefers EBGP over OSPF. But if the routes are coming from IBGP and OSPF, it prefers only OSPF. That's one point here we learn in this page. Secondly, BGP is not designed for an within autonomous system. Within autonomous system, it's your own autonomous system. If you have multiple paths, you want to do load sharing because it's your own links. You will have your own link with same bandwidth, and you want to have multiple paths when the path cost is same. But that's not the case between autonomous systems. You may have multi-homing, but you will not have the same bandwidth with ISP1 and ISP2. Uh, Physical link may have that bandwidth, but the subscription limit, the burst value, the um, committed information rate may not be same. So BGP will never perform a load balancing for us. It will only check the attribute and pick one best path by eliminating all the other paths using the attribute. It filters and say this is the path because of this attribute match. Paths are not chosen based on bandwidth or delay or hop count, but based on the policy. So these are the two takeaways. One here, another one here. Any question here? Cool. And next page is what you are expecting. If a route is learned from multiple sources, it will first check the next hop. Is the next hop a valid? Yes, I have valid next hop. Both the paths are giving both the paths are giving valid next hop. Then there is a tie. This is like a zeroth attribute. First attribute is weight. Weight, higher is preferred, but it is local to the router. Local preference, higher is preferred. It is global to the autonomous system, not to the entire world, not to the internet, just within the autonomous system, it gets advertised. If there is tie in this, then it goes to the local origin. Is this network also local in the same router? Then it prefers that than going with the other neighbor. If there is tie, then it picks the path with the lowest, shortest AS jumps, AS hops. If both the neighbors are giving me same number of hops, then goes with the lowest origin code. I is preferred over E preferred over question mark. This comes into picture only if you have dual homing and it is advertised to eBGP neighbor. The other advertisements, they are not, meaning local preference is not given to eBGP, but MAD goes to eBGP. Now, if there is tie in this 6, it prefers the neighbor, which is eBGP, then using IBGP. I have two neighbors advertising me. One is an eBGP neighbor giving me, the other one is an IBGP neighbor, and the first 6 is a tie. Then I prefer eBGP over IBGP. What if both are IBGP? See, if I have eBGP and IBGP, I prefer eBGP path. eBGP neighbor as the path, as the exit, as the direction. What if both are IBGP? If both are IBGP, which means what? They are all in same autonomous system, you will definitely have an OSPF, an IGP protocol, EIGRP or something, whichever is closest. IBGP neighbor, the closest IBGP neighbor. It will check the metric of EIGRP or the OSPF or the RIP that you have and choose that path. What if both are eBGP? See, this is eBGP over IBGP. This is both IBGP. What if both are eBGP? Then it prefers the eBGP neighbor who gave the route in the beginning, at first. That is oldest route. Oldest route. What if, just for argument, what if two eBGP neighbor gave the route at the same milli-micro nanosecond? Then the neighbor whose router ID is lower is preferred. The eBGP neighbor whose router ID is lower. The router ID will not be same in first place. One will be lower than the other. What if, just for argument, what if by mistake router IDs of eBGP are same? Then lowest neighbor IP address. And now definitely there will be only one path if it goes through this iteration. Right? When a match is found, like access list, it won't go further. It will stop there. All right. So I'll also stop here. Do you have any question?
No, I'm just stuck with the 10 and 11. What scenario we, if it
No, it won't come
happens
actually.
then?
This is just for a backup, What if some mistake has been done?
Mm.
10, 10 won't happen in first place in the real world. If it
But that is
happens,
a scenario. That is a scenario for if it has a both
same router ID.
IP.
Two EBGP with same router ID.
BGP. Okay.
How is that possible? All right. So we will